Hi everyone. Today we are going to start our journey through Unit 8. And Unit 8 is going to talk about exponentials and logarithmic functions. But today we're going to start by looking at what an exponential model looks like. Now you may have seen this before, may not have, but I'm excited to kind of dive into this with you and look at what it means for something to be exponential. So an exponential function is going to be something like this, where we have y equals a coefficient. It could be 1, it could be a third, it could be 4, it could be -2, but a number times another number raised to the x. So what makes an exponential function special is that our exponent is the variable of x. The x goes in the exponent. There are a couple rules. A cannot equal 0. Why do you think that we can't have a equal to 0? We can't have a equal to 0 because if a was 0, then this wouldn't exist and we would just have the equation y equals 0, which is not exponential, it's linear. And if we also can't have b does have to be greater than 0, because essentially if we were to put a negative number in there, if I raise something to the first power that's negative, it's going to stay negative. If I raise something negative to the second power, it's going to be positive. And so if we looked at our graph, it would start to look like this. We also cannot have b equal 1 because 1 to anything is just itself. It's just 1. And so if I had 2 times 1 to the x, it would end up just, again, making a linear equation because you'd have 2 times 1 no matter what value of x you plugged in. So let's use this equation of y equals 2 to the x. And let's look at what happens if we plug in some test values. If we plug in the values of -2, -1, 0, 1, and 2. So if I have 2 to the -2, remember what happens with a negative exponent? A negative exponent means that we do the reciprocal of 2 squared. So it's going to, 2 squared would be 4, but then the negative sign means do the reciprocal. So instead of 4, we'll have 1 over 4. So then what would 2 to the -1 give me? It would give me 1/2. 2 to the 0, anything to the 0 power is 1. 2 to the first is 2, and 2 squared is 4. And then you can see the graph over here, and we've got each of these points, -2, and notice it's just barely off the graph. -1 is at 1/2, 0, 1, 1, 2, 2, 4, etc. I didn't graph all the way to 3, but 3 goes up to, should go up to, that's actually not quite at 3, I guess. Oh, sorry, it goes up to 8. It does go up. It is on 3. Sorry, the lines were a little faint there. So a couple things I want to point out. One is that there's this very consistent curve. The curve is going to be, it's going to be changing. It's not connected by straight line segments. It's got this gentle curve. And then notice that there is an arrow on this end, and then there's an arrow on this end. And this arrow on the left end is what I want to pay special attention to. What's going to happen is that it's going to get really, really close to the x-axis, but it's never actually going to touch it. In other words, y is never going to equal to 0. Why do you think that y will never equal to 0? Y won't ever equal to 0 because we'd be saying, what number can I plug in for x that, for example, with 2 to the x, what value of x do I plug in that makes 2 to the x be 0? Well, nothing. Any number that I plug in up here, even if it's 2 to the -100th, is still going to give me a very, 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 very small fraction, but it's never going to quite equal 0. So we're going to start to see what happens. This graph is going to get really close to that line, but never actually touch it. So let's look a little bit more. Some key terms you need to know is growth factor and decay factor. So growth factor is when b is greater than 1, and decay factor is when b is somewhere between 0 and 1. So the last example that we looked at was y equals 2 to the x. That would be an example of growth factor because the value that is being raised to the x is bigger than 1. But if I had y equals, let's make it a little complicated, or 3 times 1/4 to the x, that one, because this is my b value, it's between 0 and 1, so that would be a decay. Now, an asymptote is another important key term that we need to know now and moving forward. And it's a line that a graph approaches as x or y increases or absolute value. Approaches, but does not touch. So back on this problem, the x-axis was a horizontal asymptote because my graph gets really, really close to the line y equals 0, but it never crosses. So that is an asymptote. All right, so if I asked us to graph the function y equals 4 times 2 to the x, I'm going to just say we need to pick some values for x. Let's pick -2, -1, 0, 1, and 2. And for now, those values will be perfect. 4 times 2 to the -2. All right, order of operations. Please don't fall into the trap of multiplying 4 times 2 first. Instead, we need to take care of our exponent. So I'm going to do 2 to the -2, which is 1/4. And I'm going to have 4 times a fourth, which gives me 1. Go ahead and fill in the rest of those values. What are the next 4 values when I plug in -1, 0, 1, and 2 for x? So these are the values that you should have gotten: 1, 2, 4, 8, and 16. Do you notice anything interesting about those numbers? They're increasing by powers of 2. They're being multiplied by 2 every time. Very interesting. I wonder if that's a pattern we'll see. Let's keep going. So I'm going to graph these points: -2, -1, or sorry, -2, +1, excuse me, -1, +2, 0, 4, 1, 2, 3, 4, and 1, 8, 1, 2, 3, 4, 5, 6. And then actually 2, 16 is going to go off the graph. So I'm just going to do my best. And notice that this curve is a little bit less severe until I turn it this way. Then it's going to go like this, and it's going to taper off toward the x-axis. So that would be the graph of 4 times 2 to the x. So now they're going to give us 2 points on the graph and ask us to write an exponential function. So let's look at this. We've got x and y, x and y. I can plug in x and y for an equation. I can plug in, let's use the smaller one. So I'm using my function y equals a b to the x, and I'm going to plug in what I know. 4 equals, a b squared. Now, what I'm going to do, and this might not seem logical at first, but I'm going to say, you know what, a does not have an exponent on it, so let me just move that b squared to the other side. Let me just get a by itself and see what happens. Oh, if I write the right letter. And I get 4 over b squared equals a. Okay, that doesn't seem like it helped a whole lot, but bear with me. I'm now going to use this other point. I do have to have 2 points in order to do this. So I'm going to plug in what I know from this one. I know that 16 equals a b to the third. Now, I intentionally didn't, well, I'll put the a there first. But here's what I know. A equals 4b squared. Oops, that's not what I wanted. So what if I replace the a in this equation with what it equals here? 16 equals 4 over b squared times b to the third. Now, I remember from the last unit that if I have bases being divided, it might not look like they're being divided, but it might help if you think of it like this. This one's in the numerator, this one's in the denominator. What operation do I do with these exponents? I subtract them. And so I'm going to get 16 equals 4b, because 3 minus 2 gives me 1. Now I can solve for b. That's helpful. Okay, I can divide both sides by 4, and I get b equals 4. All right, I've got one of the 2 letters that I need if I'm looking at my final answer. Let's put it over here. We've got y equals a, and then I know that it's going to be 4 to the x. But let me plug this in. to this so that I can solve for a. I have 4 over 4 squared equals a. All right, so this would give me 4 over 16 equals a, which reduces to 1/4. So I'm going to have, let me put that in parentheses, that's a good practice to be in, 1/4 times 4 to the x. And let's just do a quick little check. If I plug in 2, 4 squared is 16, and 16 divided by 4 is 4, so that one works. If I plug in 3, I get 4 to the third, which is 64, and 64 divided by 4 is 16. So that's awesome, that works. So our final answer is y equals 1/4 4 to the x. Now, I would like for you to try this one using kind of the same steps. Start by finding what is your a value. When you solve for a like we did up here and got 4b over b squared, we should get a equals 1 over b. All right. Now, if you use 2, 3, you probably got something similar. You would have gotten a equals 1 over b squared. Or sorry, 3 equals. One, 3, sorry, a equals 3 over b squared. There we go. Now, next I would like you to use your second point, whichever one you didn't use, and find the value of b, just like we did up here to get b equals 4. All right, so here's what I got when I plugged in 3 and 2 for y and x, and then also plugged in 1 over b for a. I got 3 equals 1b because I subtracted my exponents, and b equals 3. My final step is to plug those in and find the value of a. So when I plug in b equals 3, what value do we get for a? A equals 1/3. Since there was no exponent on this, all I had to do was substitute the 3 for the b, and that was it. So when I write my final answer, it will look like y equals what? 1/3 times 3 to the x. And that should be our final answer. So we've got one more page to look at here. We're just going to look at, are these functions exponential, growth, or decay? So remembering that growth is when b is greater than 1. Decay is when b is between 0 and 1. So I'll do the first one. I want to make sure that I'm looking at my b value. So which one of these is b, 100 or 0.12? It's 0.12. And 0.12 is somewhere between 0 and 1, so that means that this is an example of decay. Even though 100 is considerably more than 0 or considerably more than 1, it doesn't mean growth. It just means that this is what determines our growth or decay. So try the next two. Is letter B growth or decay, and is letter C growth or decay? Letter B is growth, and letter C is decay. Because here, 5 is greater than 1, so that means that it's growth. And here, 1/2 is between 0 and 1, and so it is decay. Okay, the last thing I want to look at is how to do a graph where we're graphing a decay. And just hypothesizing here, what do you think is going to happen to our graph? When we graphed with a growth factor of like 2x or 4 to the x, it went like this. So what do you think is going to happen when we graph a decay function? Okay, let's test it and see. I'm going to plug in the normal test values that we're going to be using of -2, -1, 0, 1, and 2. And when I plug those in, I get 100 times 0.1 to the -2. 0.1 to the -2 is the same as doing 1 over 10 to the -2. And so when I square 10, I get 100, and then I do the reciprocal. And so instead of having 1 over 100, I have 100. So essentially I have 100 times 100, which is going to give me this, 10,000. That's a big number. What about if I do this? 0.1 to the -1, that would be like having 1/10, but then do the reciprocal, so 10. So this is going to give me 1,000. 0 is pretty easy. Anything to the 0 power is what? It's 1. So that would just be 100. Then I've got 100 times 0.1 to the first. So that'd be like 100 times 1/10. So that would give me 10. And you should be seeing a pattern happening here. Each time we're dividing by 10. So by the time I get down to here, I should be at 1. This is 1 over 100 now because it's squared. And so that would be, when I do 100 divided by 100, I get 1. So just for the sake of being able to fit a few more points on here, let's say that each of the y values is worth 10. So 10, 20, 30, 70, 80, 90, 100. Okay. So I'm going to graph, I can't graph 10,000 or even 1,000, but I can graph 0, 100, and 110, and then 2, 1 would be like right there. So notice I do still have a curve. It's a much steeper curve, and we'll talk again about what kind of affects that shape as we go. And I want that to not touch there. That kind of answers our next question. And then it's going to keep going up and up and up. And then it says to identify the horizontal asymptote. So horizontal, meaning left to right. What line is my graph getting really close to, but it won't touch? Again, I see that it's the x-axis. So the horizontal asymptote, is the x-axis, but if we write the equation of that line, what's the equation of the line for the x-axis? It is y equals 0. And there you have it. This is just an introduction to exponential functions. We're going to start to look a little bit deeper into some of the properties of exponential functions and how to graph them with translations as we go. But if you have any questions in the meantime, please let me know.